All right, guys, today we're going to be looking at solving exponential equations. We've been looking at exponential expressions. Now we're going to basically set two expressions equal to each other, and that's what gives us an equation. Your I can statement for today is to solve simple exponential equations. And believe me, when I say simple, I do mean simple. They're going to stay very basic in this class. So if remember that we are taking notes while we watch this video. And I want you guys to be taking Cornell notes as you go through this video. So go ahead and pause the video now if you haven't got those ready. All right, first definition to talk about today is the power property of equalities. Basically, it means that we have a power property or an exponent property in equations. And what that says, and I'll explain this in just a second, it says for any real number that is greater than 0 and not equal to 1, if I take that number and raise it to the power x equals that same number to the power of y, then x must equal y. Let me show you what I mean by that. I have an example here. If I have 3 to the power of x equals 3 to the power of 7, well, what must x be? Well, because my bases are the same, then x must equal, in this case, 7. So what this basically means is I can ignore the bases and say, what's left? Now, the only reason I should be able to ignore my bases, though, is if the bases are the same. In this case, the base is 3. So, in this case, because the base is the same, x equals 7. Same thing with over here. If I have 5 to the power of n equals 5 to the power of 1/2, because my bases are the same, I can ignore them. And what's left? N equals 1/2. Let's look at some other examples. Why don't you try this one? Pause the video and see if you can solve for x here. All right, well, you should have noticed that the bases are the same. So we can ignore those bases and just say that x equals 3. Okay, try this one out. All right, you should also notice that the bases are the same, so you can ignore them. And just say n equals 3. Okay, let's try this one out. 3 to the power of n minus 2 equals 3. Let's see if you can apply what you know about these exponential equations already and solve for n on this one. All right, because my bases are the same, I can ignore them. What's left is n minus 2 equals 3. And then I just add 2 to both sides to get rid of the constant. Leaves me with n equals 5. All right, and one more. Go ahead and pause the video and give this one a shot as well. All right, so we notice that my bases are the same. So I can ignore the bases and write 2m plus 2 equals 8. Subtract 2 off both sides to get rid of the constant. Leaves me with 2m equals 6. So I'm going to divide both sides by 2 to give me m equals 3. 6 divided by 2 is 3. All right, so that's a basic exponential equations there. Let's move on and talk about what happens if my bases are not the same. Here I have 6 to the power of x equals 216. The basic concept behind this is because my bases aren't the same, I can't use the power property of equalities. So what I need to do is somehow change this 216 to 6 to the power of what? Let me bring up my calculator here, and I'll show you what I mean by that. So let's see. If I did 6 to the power of 2, that's 36. It's not 216. And I could keep on trying to go up every time here. 6 to the power of 3. There it is. It's 216. So that's going to be power of 3. Now that my bases are the same, I can rewrite this as x equals 3. So basically what I did here is I rewrote 216 as 6 to the power of 3. Now that could take a lot of guessing, so let me show you how you can do this by hand so you don't have to sit there and guess on your calculator all the time. What I want to do is I want to take 216 and I want to divide it. Now this is upside down dividing. I call it the upside down cakes. I want to divide that by 6 because I want my base to be 6. So that's what I'm going to divide it by. Now you can open up your calculator and say, what's 216 divided by 6? Well, that's 36. So I'm going to come back over here and say, well, this is 36 here. And then I'm going to divide again. Divide by 6. Well, what's 36 divided by 6? Well, that's 6. The question is, once you get down here, once you get down to 6, once you see your base once more, how many 6's do you have? Well, I have 1, 2, 3 6's over here. It just so happens to be that number right there, and that's exactly where we get 6 to the power of 3, which is why now we can ignore our bases here, ignore those bases, and just say x equals 3. Let's do that again. Let's see if you can use that to solve this one. Go ahead and pause the video and give this one a shot. Okay, well, let's give it a shot. I know that the base is 9, so I want to rewrite 729 with a base of 9. The question is, to the power of what? To the power of what do I need to write there? Okay, so just like in the previous example, I want to take 729, and I'm going to divide by the base that I want, which is 9. 729 divided by 9 equals 81. And I'm going to divide by 9 again. And you should get 81 divided by 9 is 9. How many 9's do I have? Well, I have 3 9's. 1, 2, 3. So that 3 goes here. Now that my bases are the same, I can ignore the bases and just say n equals 3. All right, here's another one. The bases are the same in this case, so I can just, why don't you go ahead and pause the video, give that a shot, and we'll resume here. All right, bases are the same, so we can ignore them. It leaves with n minus 2 equals 8, and then just add 2 to both sides, which leaves me n equals 10. All right, try this one out. Go ahead and pause the video and give this one a shot. All right, my bases are the same, so I can ignore them. It leaves me with x plus 4 equals 11. Minus 4 from both sides to get rid of the constant. Leaves me with x equals 7. Let's try the next one. What about this one? 128 equals 2 to the power of m plus 2. Well, my bases aren't the same, so I'm going to have to change the base of 128 to 2 to the power of something equals 2 to the power of m plus 2. Question is, what goes here? Well, I'm going to take 128. I want my base to be 2, so I'm going to divide by 2. And if you want to, you can pull up your calculator at this point. Say, what's 128 divided by 2? 64. Divide that by 2 gives me 32. You guys can check this in your calculator if you'd like. 32 divided by 2 is 16. 16 divided by 2 is 8. 8 divided by 2 is 4. 4 divided by 2 is 2. Well, there's my 2 again. So how many 2's do I have? 1, 2, 3, 4, 5, 6, 7. So 2 to the power of 7 equals 2 to the power of m plus 2. Because my bases are the same, I can ignore them. 7 equals m plus 2. To get m alone, we need to get rid of the constant by subtracting 2 off both sides. And there we have it. M equals 5. Okay. And that's all I have for you guys today. Why don't you guys go ahead and try the exit ticket out. If you don't have the exit ticket with you because you're watching this from home, go ahead and go back to these problems and review them and write up some questions for your Cornell notes. You guys have a great day.